So thank you very much for joining me after lunch. For those of you who have been to the talk just before lunch on Rust, well, we're going to have quite a lot of similarities in complexity of the way to reverse our malware. It's no longer Rust. It's going to be another programming language, but still there are lots of similarities there. So before we get into the talk itself, this is how I'm going to organize it. First, I'm going to run you a little bit of background on Flutter in case you do not know exactly what that is. And also, perhaps you know what Flutter is, but not exactly the internals of how to reverse it. So I'll get a little bit into that. And then after that, we will get into some malware analysis of malware using Flutter. Yeah, I was going to put that slide at the end, but I know I'm going to be a little bit short on my slides till the end, so I'll rather put it at the beginning. Thank you very much to two different groups. First, Pancake, who is the maintainer of Radari 2, which is a disassembler, and also the Dart community, who were very helpful for this research. When I asked them silly questions, because I'm not a Dart developer, okay? We'll see a little bit afterwards. Dart is the programming language for Flutter, okay? And, well, I showed them lots of assembly and asking them kind of, some help here and there, and they were always very helpful with me. So thanks to all of those. Flutter. So Flutter is a software development kit. It is brought to us by Google. And I'd say that its main advantage is that you can use the same code and have that run on many, many different platforms, such as iOS, Android, Linux, Windows, Mac, etc. Okay. Using statistics of AppBrain, we see that it's already in 2024, around 6% of applications are using Flutter, so it's growing. And this makes it interesting to look into it in terms of malware analysis, of course. Flutter applications are written using the Dart programming language. This is a working example, which is here, which, as you might, I'd say, easily recognize, it's going to post this message, virus built in 2024, and it's going to post it on this local web server, which is running on port 9000, sorry. I think you'll at least agree with me with that, well, it looks like a little bit like C, and that it's easy to raid. So that's also something which is cool about Dart. The other thing is that, well, it's not the first time that we have portable languages. Java is just like an excellent example for that. Yeah, you can run your Java programs on so many different platforms. But we haven't ever had Java applications on mobile phones. Well, we did, for those of you who are as old as me. We had J2ME and JavaMe, which are specific profiles for mobile phones. But it wasn't like the entire Java platform, but selections that would go on mobile phones. Here, we don't have virtual machines for that, for Java on mobile phones, because mainly there's a performance issue when it's not working that well there. To solve that, Google said that for Flutter, everything would be compiled natively, which means that you're running on x86 64, well, you're going to compile for that. You're running on a smartphone which runs ARM, well, you're going to compile for ARM, okay? And you get native performance on all of those platforms. The impact in terms of malware analysis is that all the tools that we have, which are traditionally used for Android malware analysis, are not going to work, because the code which is for Flutter, is not on the Dalvik side, coded in Java or in Kotlin. So every tool, such as APK tool, Smelly, all Smelly-based tools are not going to be useful in that case because everything is going to sit in a native library. And in the specific case of Flutter, remember this name. You'll have to go into libapp.so. The name is fixed. You can already dig into that one and reverse this one. So why is it difficult to reverse Flutter? It's as painful as we had in the previous talk with Rust, okay? Well, true, we do understand ARM and x86 instructions, no problem with disassemblers on that point. But the issue is that disassemblers do not know the binary format for Flutter, which is called Dart AOT snapshots. So as they don't know the binary format, well, they are not able to get into it and to make sense out of what they are reading, and that's a big issue. And on top of that, the format is not documented. Well, source is the documentation, which is like a bit difficult, okay? And also, well, there are still significant changes, even in the binary format, every now and then. So if you're like an open source developer and you intend to, I don't know, to do some work on Flutter and develop a tool, well, you don't know if your work is going to last for, I don't know, 1 year or just 1 month, which is a big issue. So if you still want to put your native library in the disassembler, well, one of the other issues you're going to face is that you don't have any symbols. This also happens very often. I'm sure you've analyzed malware without symbols in other cases, well, at least stripped. But usually our disassemblers have some kind of inner mechanism to recover the symbols so that you know this is calling, I don't know, printf, this is calling this or that part of the Windows API or something like that. Here we don't have the support for Flutter yet, which means that we just get like, well, an address, and we don't know where it is pointing to. Other things, when we are reversing, well, we get strings, okay? So you'll see strings. If you do strings my binary, you'll see the strings appear, but you will never get the cross-references because what happens is that in Dart, all strings are accessed indirectly through a concept which is called the object pool. And disassemblers have not implemented this mechanism at all. So you were stuck, unfortunately, with strings, but no way to know where they are accessed. Yet another difficulty is that Dart is using specific CPU registers. If you have reversed Go, for instance, you have the same mechanism which occurs there. And if we have a look at those two lines, okay, well, if you don't know that x15 is the stack pointer, it's like a little bit obscure. But when you know it's the stack pointer, well, you recognize that we're pushing something, 2 elements on the top of the stack, and then saving the pointer. And then it makes clear, it gets clear that you are like doing something that you do at the beginning of each function to save your context. Okay, so it's really important to know what those registers are doing. Another very important register for Flutter is this one, the object pool x27. Of course, the registers are per platform. It's going to be different registers for ARM32 and for x86, for instance. And finally, well, there are plenty of things which are just not non-standard, okay, on Flutter, and which are going to cause issues to disassemblers, like representation of integers. Well, in binary for Flutter and for Dart, when you want to represent 1, what do you know? Well, you're presenting 2. Okay, so, well, it's not very difficult, but you need to know it, okay? And it's like that for all integers. Now, we're going to get into malware analysis there. Now, I have a small story to talk there about malware, is that when I arrived in Dublin yesterday at the airport, I used a taxi, and the taxi driver was really very, very interested in cybersecurity. And he started asking plenty of questions to me, and he was like excited. Nearly thought I should invite him, but well. And it's quite funny because at the end, he kind of gave me a few tips for my talk. I didn't ask for any, but still, he gave me tips. And he told me, oh, you're having them just after lunch. If you want them to listen to you, you've got to scare them. Okay, so I'm sorry, I don't really have any scary news, except that we're going to analyze malware. So, the two main families that we have for Flutter malware is SpyLoan, this one, and Fluhorse. It all started like just a little bit before 2023. The dots there means that the family started without using Flutter, okay? It was already there, but not using the Flutter framework for its implementation. So you've got those, okay? And we're gonna look into those, and the ones in gray are riskware, not malware. What can we do as a malware analyst when we have Flutter malware? Well, we've got two different tools, basically. One is the JEB disassembler and decompiler. As far as I know, it's the only one which has some native support for Flutter. IdaPro does not, Ghidra does not, Binary Ninja does not, and Radari, as we will see, it's coming, but does not really initially. Okay. So you've got this one. It's not perfect, and it could be really very much improved, but at least you've got something at the beginning which will help you do the analysis. The other tool is called Blutter, and it's an open source tool, and basically it will produce only text file as output, and mostly scripts that are going to help you recover mostly the symbols and everything in your disassembler, IdaPro and Radari. It works well, and it's the best tool, in my humble opinion, that we have so far, but it is only working for ARM64. If your malware is ARM32, well, too bad for you, it's not gonna work. Let's get into this one. So let me just be clear, those are not discoveries, okay? They were discovered at the end of 2022. What the contribution of the talk is more how we can improve our analysis of this type of malware, because at that time, at the end of 2022, it was really a big issue to understand what the Flutter side was doing. So SpyLoan, like the name can suggest, it's a loan scam. It will attract people in getting a loan. And once they have got the loan, well, it really harasses the victim into repaying the loan even before the end of the normal end of the loan. And it really goes very bad, like it's threatening to leak your pictures, contacts, GPS location, and everything to people, okay? In terms of implementation, all the malicious parts were actually implemented on the Delvik side in Java and in Kotlin. So we didn't have, at that time, any issue analyzing it, because those are the traditional tools of Android would work, okay? So we could analyze pretty clearly the code written in Java, but everything that was on the Flutter Dart side was pretty much opaque. We didn't get into it, nobody got into that side, because it was too difficult and would take too much time to really understand what was happening. Now, using Blutter, we can do better than that. And it's really interesting, but we can understand what is happening in this black box. For instance, at some time, The malware is going to create a repay URL to send to the victim to pay back the loan, okay? So we knew what that URL was, but we didn't know how it was constructed. And now with Blutter, we are able to uncover the algorithm for that. We see that actually it's constructed in two different parts. First one, it gets the first part of the URL from a remote server, and the other part is decrypted from an encrypted plain ciphertext, which is in the Flutter side. We're going to get a little bit down into that, into the assembly. Now, don't be scared. I'm going to go slow so that you can really follow along what's happening. This is the typical output of Blutter. In blue, you have the addresses, okay? In red, here, you have the instructions. And now you've got to pay attention to the indentation. If it's not indented, it means it's like a Dart upper layer instruction. Here, array load, which means that it is going to read a character from an array. This instruction does not really exist. I mean, it's a high-level instruction. It is implemented by the two other instructions, ARM instructions, which are there and which are indented. That's the way it works. So if it's indented, it's ARM. If it's not indented, it's a high-level instruction. And it's nice because with the names that we get of the high-level instructions, well, we understand what is happening. So here we have decompressed pointer, because actually we understand that our addresses are not stored, the full address is not stored in memory because it would take too much space. We just store the 32 lower bits, and then we're adding again the 32 upper bits to get a full address to go to. So we understand how it's working. And here, load int 32 instruction means that we are converting a character into an integer. Then we have an instruction, EOR, so this one is the XOR instruction in ARM. And we see that we are doing an XOR with a hard-coded key, which is 18, which is there. And then we are converting back our integer to a character. And there you go, you've reverted, hooray, your first encryption algorithm in Flutter. And it's pretty simple, okay, fortunately for us. Basically, you take that kind of encrypted string and you do an XOR with 18 on it, and you will get this part of the URL. Let's go to another one. Fluhorse is the other malware that I wanted to discuss with you. So it appeared a little bit afterwards, and what's really important about that one is that all the malicious parts are written in Flutter. So if we are not able to get into the black box, well, it's really a big deal, okay? This one is posing as a e-toll application. The victims will get like a fake login page. They were asked for their credentials, and then inside there, so it's going to basically to ask them to enter their credit card, and then it's supposed to make them pay for how much they use, I don't know, this or that motorway or something like that. And the malware will even actually intercept the SMS, the second factor authentication SMS, to grab the code there and to forward it to the malware authors so that they can complete the payment. And we're actually going to have a look into that. So this is Dart code that I supposedly wrote from the assembly, which is actually stealing the SMS and sending it to the remote server, which is controlled by the attackers. Okay. What's important there and what we need to understand is that it's using Dart's asynchronous function. So that's why you have this keyword async and await, which means wait a little bit for HTTP posts to complete. And also, when you have those asynchronous functions, well, they're going to return a generic type, which is a future, and which means that, well, you don't have your return type immediately. At first, there won't be anything, but if you wait long enough, you will get a string in there. That's the way it is done there. And in the assembly, this is what it looks like. So you see again this async keyword. You see that we're taking here, so you know it because of that type arguments, that we're taking an argument which is a string in there. It's not specified here. And we know that we are going to return a future, which is there. So just notice here that Blutter's prototype is not complete, okay, because it doesn't show the arguments nor the return type. That's because, well, it's an open source program and it's still waiting for contribution, so it's not perfect yet. Other thing which is important if you are reversing Flutter malware is closures. And we mentioned, there was a mention of closures also in the talk about Rust. So a closure is basically a function where you can also capture some surrounding state, a variable or something like that. Okay, it's present in Dart and in some other languages. When you have a look at that in the assembly code, well, we're not going to get too much in the specifics, but we see that we're loading something from the object pool. We're loading actually the closure object. And then we're allocating the closure, and then we are calling it. So that's interesting to know how it's working, but as far as we are concerned, the only thing we are concerned about is this, the address of the closure. Because at first, if we have a look at post SMS, in there, we wouldn't find anything about the HTTP post. And said, yeah, come on. Post SMS looks like it's posting something, so where is it doing the work? Well, it's doing it in a closure, so you've got to be able to find the closure, identify which closure is actually being called, and this is where you actually will notice that the HTTP post is being done. Demo. I'm going to do a very short demo because we don't have that much time. I'm running Blutter in a Docker container because to install Blutter, it's sometimes a little bit, there are sometimes a few issues because it's using GCC 13, which is not always simple to install on all systems. And also I'm using a fork with a few modifications, that's why. So we're going to use Blutter on this malicious sample there, and I'm going to put it in this output directory. So actually it's retrieving, doing a git clone on an external repo to get the Dart SDK, which matches the sample. It's 2.19.2, okay, which is reasonably old, okay? I'd say it's like 1.5 years old, and it's going to take a little bit of time. So I'll let that complete while I jump to the next slide. I'll come back to that. So for the conclusion, are we going to see more Flutter malware? Well, 1 year ago, I was honestly thinking that in 2024, we'd see lots of Flutter malware. It hasn't happened so far, so my crystal ball was wrong, okay? I don't know why, because the language and the fact that it is portable is really interesting. And the other thing is that for malware authors, it's so difficult for us to reverse Flutter that they don't really need to put obfuscators or packers. Okay, but on the other side, they've got to learn a new programming language and some concepts such as the futures. Sound null checking, and also the description of the layout sometimes can be a little bit cumbersome. Have I finished? Yes, I finished. I'm getting back to here. So the output is in the outputs directory. And maybe you can see it better like that. Well, actually, we have text files and a few directories. For instance, in the R2 script directory, well, you have a script which is going to help you get the symbols in R2, okay, in the disassembler. If you want the same thing for IDA Pro, well, you go in the IDA script directory, and you will get some other scripts for IDA Pro. This will really help your life if you're analyzing a Flutter malware. And also, you've got some text files like here. Whoops. This is the object pool, so you can see exactly each entry of the object pool, what is at this or that offset, which is really interesting. And if you want to see the assembly that I showed previously, well, there it is. So here, I made it on purpose. This sample is obfuscated. So normally you would see like nice, meaningful names. Of course, in that case, it's not the case. You get those. We can, however, look for the main. Let's do something like that. Yeah, it's in arc.dart. And there we go. We have the main of our Dart program, which is there, and you see all the instructions. Okay? Let's go back there. Lessons learned. Well, if you are developing a new programming language or a new framework, I'd say that, well, don't be too naive. One day or another, somebody who's malicious is going to use it. So it's really great if you can supply some help, some tools for malware analysts to help you defend against those bad guys. And that being said, it means that we really need, for instance, documentation for binary formats. I don't know, for the DEX, the Dalvik executables on Android, we have a very good documentation for that. Why don't we have documentation for Dart AOT snapshots? We really need that, okay? We need also tools such as readelf, but that would be able to process Dart AOT snapshots. And we don't have that because we don't have the documentation, and we'd have to go through all the source code line by line to understand what is happening, and that's really cumbersome. I tried to provide some tools there, but it's really work in progress. You'll have the links in the slides. It's just the beginning of the work, but it really needs lots of improvements. The other thing is that, well, if you're a reverse engineer, well, we often rely so much on our disassemblers or decompilers that we forget that they are doing lots of job for us, okay? So in the case of Flutter, the first time I had a look at the output, I was kind of a little bit desperate until I understood, oh, well, normally the disassembler is doing this and that for me, and that's why I had to work back onto that and to understand how it is working. So it's really interesting to see how it is working for that. Then you've got a few references. I'm not going to read that. In the paper, by the way, there are some more malware that we are analyzing, but I thought it would be confusing for a presentation to put too much, okay? So I preferred just to limit it here. And that's all for me, so thanks very much for your attention.